Hi, and on we go with our trigonometry. This is the last last set of videos from this trigonometry section. There's a few bits and pieces we've got to do with regard to this one, and what we're looking at in this is expressions where we're looking at adding together two ratios, so like a sine plus a cos, and we're going to see what happens. So what we're going to do is we'll look at what happens when we write the sum of a sine and a cos function as a single function, and how that's going to allow us to deal with things, solve equations, come up with minimum and maximum points, this kind of stuff. First thing I'm going to do is we're going to take a look at y equals 4 sine x plus 3 cos x. And all I'm going to do to begin with is just I've plotted that graph, and there it is. And straight away, what do we notice? Well, hopefully we're noticing that the sum of these two trig functions, a sine function and a cos function, added together, has given us something that is still exactly the same shape. So it's clearly got the same shape as a sine curve or even the cos curve, because they basically are the same shape. Now I've put the blue curve on there is y equals sine x, because what I'm going to do is compare my red curve to my blue curve. And what you hopefully can see straight away is, firstly, we've got a horizontal translation, so I've marked the point where it goes through the x-axis, and tell you what we've got is, I'm just going to take that off for a second again. So if we have a look at what's going at this point here, that point has now shifted to there. If we have a look at the same here, at 2 pi, that's now shifted to there, this point here. So we've got a horizontal translation of however far that is. And in a minute we'll figure out how big that translation is. The other thing that's very obvious is that our red curve has been stretched. It's got much bigger peaks and troughs. So we've got a vertical stretch going on, so we've got a scale factor. So essentially what's going on is we've got our blue curve can be transformed into our red curve using a horizontal stretch and a horizontal shift, and a vertical stretch. So we can describe it as a result of two transformations, and we know how graphs transform, we know how to phrase it, so that is going to give us a way in to be able to figure out what this thing is as a single trig function. Okay, so let's do that. Let's start off by writing our function as a single sine function. And the first thing to notice is I've used that kind of that equal sign with 3 lines, which means equivalent to. This thing here is the same as a single sine function with certain values, this value r and this value alpha. And we know that r is going to be our stretch, and we know that alpha is going to be our translation. Right, so what we've got is that right hand side, this thing here is in the form of an addition formally, so we can write that in its expanded version. So I've got r sine x cos alpha plus r cos x sine alpha. So that thing there is sine a plus b multiplied by r. And now if we're saying that these two things are equivalent to each other, then the value of what I've got on this side has got to be the same as the value of what I've got on this side. And so we're going to pull that trick that we've probably done in a few other situations where we're going to do a bit of equating. What I'm going to do is look at the sine x terms. If this whole thing on the left hand side is going to be the same as this whole thing on the right hand side, then those bits I've got now coloured in green are going to have the same value. And what that means is I've got the sine x there, the sine x there. That means that that 4 there has got to have the same value as the bits over here, which is r cos alpha. So from there we can pull out that statement. If we do exactly the same with the cos terms, again, this bit circled in blue has got to have the same value as that bit circled in blue. They're both in terms of cos x, so this r sine alpha has got to have a value of 3. So there we go. So what we've got is essentially a pair of simultaneous equations. There's a couple of ways we can go about it. What I'm going to do is just do a little bit of rearranging. So I'm going to do that. And then if I know that cos of an alpha, I've got a triangle here with, that's alpha, no, cos of alpha, adjacent over hypotenuse. So I can put those values in. And clearly this sine alpha is opposite over hypotenuse. So that means that's the 3. And there we go. There's our 3, 4, 5 triangle. So straight away we've got r equals 5. Now if we know that r equals 5, basic simultaneous equation stuff, if I know one of my variables I can figure out the other one. And yeah, again, there's a number of ways of going about it. What I tend to do though is just look at this and go, well, you know what, I'm going to look at my triangle and say 10 alpha is 3 over 4, and just, you know, do it that way. So what that gives me is a value of alpha, which is 36.9 degrees. So what that means is that this expression here, our 4 sine x plus 3 cos x, we originally had it like this, and now we know r, we know alpha, and so there it is written in terms of a single trig function, a single sine function. Let's go back now and have a look at our curve and just see what those things look like on our curve. There they are, and you can see that shift is it's x plus, so it moves the wrong way, so it's shifting 36.9 degrees that way to the left, and we've got a stretch, whereas this point here was at 1. Yeah, you can see where my cursor there is, the y value is 1. If you have a look at this point up here where my cursor is now, you can see on the scale it's at 5, so we've got a stretch scale factor 5. Okay, so what we've got here fits precisely with what we're seeing on the graph. Okay, happy days.